Hello everyone, welcome back to another video in the channel. Myself Akshit Mishra, and as I promised in the community post, I am here to present the solutions of two of the problems from CodeChef Starters 76. I had quite a good contest last time, so that's why I decided to post solutions also along with the normal upsolving videos. So here is it, our first problem. It was called make array odd, and let's just read the problem statement. We are given an array A and an integer x, and we are allowed to perform the following operation on the array. So let's read the operation. We have to select two distinct indices I and j and set both ai and aj as ai XOR aj, and this whole quantity would be ORed with x simultaneously, and here XOR and OR denote the bitwise OR and bitwise OR operations respectively. We have to find the minimum number of operations required to make all the elements of the array odd, and if it is not possible to do so, we have to print -1 instead. Okay, so that's what was the problem statement. Let's read some sample inputs. So if we have an array of size 3 and suppose x is 6, then the minimum number of operations which are required are 0, because all the elements, as you can already see in the array, are already odd. 5, 7, 9, all of them are odd, so we don't require any operation. And in the second case, if we have 5 numbers and we have 4 as our x, then we require 2 operations. So I hope you understood the problem statement. Now let's understand the logic behind the problem. Know basic binary operations, then we would know that odd numbers have 1 in their end and even numbers have 0 in their end, which is their least significant bit. So let me show you an example. Like 0 is an even number. In their binary form, their least significant bits, like even numbers, have 0 in their end, as you can see here, and 2 and 4, and odd numbers have 1 as their least significant bit. Okay, now what was given in the question? It was given in our question that we have to make all the integers in our array as odd numbers. So it is quite clear that we have to convert their last bits or the least significant bits into 1 if all the numbers are if the last significant bit of the number is 0. Otherwise we can make the number stay as it is. So now let's talk about the OR and XOR operations now. So if we observe the XOR operation, so like if we XOR 2 with 1, then if we make it in binary form, it's 1 1. So what is XOR operation? In a XOR operation, we if we have the same bits, if we have the same binary representation, then we return 0, and if the two binary numbers are different, then we return 1. So 1 0 XOR 1 would give us this, and this would give us 1, and here we can assume to be 0, and this XORed with this would give us 1. Okay, let's take another example to make the pattern a little bit more careful. Like we XOR 3 with 2. I suppose you know this is equal to 3, which is an odd number. Okay, now For XORing 3 with 2, let me change the color. We have 1 1 for 3, and while XORing with 2 we have 1 0. XORing these two would give us 1, and since these two bits are same, then we would get 0 here. Answer is 0 1, which if converted into decimal would give us 1, which is an odd number again. So you observe the pattern here, that if we XOR any number, any even number to be more specific, with an odd number, then we are quite sure that we would get an odd number. So that was the first takeaway from this question. Discuss the second observation for this question. Now, what is the OR operation? In the OR operation, if we have any bit equal to 1, regardless of others being 0, we would get the result as 1. Okay, so suppose we have let's say arbitrary numbers 9, and we are ORing it with, this is the OR symbol, with 4. Okay, so 9 can be represented like this 1. Okay, you can assume this bit to be 0. First, comparing these two, we have a 1 here, so we would get a 1 at the end, and we don't have any 1 in this position, we would get a 0 here. We have a 1 in this position, we would get a 1 here, and again we have a 1 here in this position, so we will again get a 1 here. And now this number, if you recognize it, then it's 13, which is again an odd number. So it's another takeaway for this question, that if we OR any number with an odd number, it is quite sure for us that we would get the result as an odd number. So now let's talk about the operation which was given in the question. So we were given an operation in the question of this expression with x, that was given to us. Now, by the previous two observations, it is quite clear that if any of these two numbers is odd, then we would get the result as odd. And if we get an odd result here, if this quantity becomes odd, then the result of this quantity, regardless of being odd or even, would definitely become odd. That's quite sure for us, I guess. So if any of these two numbers are odd, so let me write it down, of these three numbers is odd, then we would get the result as odd. Now if all the elements of the array, like if we have to pick any aij, but if all the elements of the array are even, or let's say x is also even, then it is quite sure that we would never be able to make the number odd. So if all the numbers are odd and x is also odd, then definitely the answer would be -1. Otherwise we would always get odd numbers. Okay, now how to find the values and aj, ai and aj. Okay, if all the numbers in the array are even and x suppose is odd, if x is odd and all the numbers in the array are even, you know that what we have to do now? We would be making pairs, and each of the pair would be feeded with this x. So we have 6 numbers in the array and x is given us to be odd, then what we will do, we will select any two I'll select this one and this one and apply that operation of AIs or AJ and ORing it with X, as X is odd here. X is odd, so the result would be odd. Okay, and again we would make a pair of these two, then again we would make a pair. So you see, for an array of size 6 we required 3 operations. Okay, we required 3 operations for an array of size 6 for it to turn into all numbers, for all numbers of that array to turn into odd if all of them are even. Now let's say the array was of size 7, array was of size 7, then what we would have to do? Then it's a simple fact that we would first OR all the elements like this, and then make a pair with any of the random element, because that element would get suffered because it is already odd, and XOR that element with an even element, then the number would have no effect because it is already odd, so it would remain as odd number, and we would get one extra operation. So if there was an odd size array, we require even by 2 plus 1 operation if all numbers are even, and if we had all numbers, if the size of array was even, then we require the size of the array by 2. So to get it into more general purpose, we would require n plus 1 whole divided by 2 operations to turn the entire array into an odd number. So would this run for this? Let's say if n is equal to 6, we would get 7. 7 upon 2 would be equal to, it is quite evident that on dividing this, the quotient would be 3. So this formula works. But what if the numbers in our array are odd also? Then what we will do then? Let's check. So suppose we had 7 numbers in an array. Okay, we have 7 numbers in an array, and let's say 2 of them are odd and remaining 5 are even. So, and let's say for both the cases, if X is odd and even number, for both the cases we have a clear observation that we would first make a pair of these two elements, let's say, then we would make a pair of these two elements if X is odd, and for the last one we would make a pair with any of these numbers. So as discussed previously the size of the array entirely was taken. Here only the even number size will be taken if X is odd, but if X is even, what we have to do then? We would have to make a pair with this element, which is an odd number, and first we would make a pair of these two, then this number has become odd number. It can make pair with this, and this can make pair with this, this can make pair with this, and this can make pair with this. Okay, so how many operations does this require? 1, 2, 3, 4, 5. It requires 5 operations. So if X was odd, then we require, let me write it more clearly, if X, okay, so this is the general case. If X is odd and if odd number is an array, then we would require even plus 1 by 2 operations. This would be the same case as we had previous case where all the elements of the array were even. and we would just consider this size of the array because other numbers are already odd. And if x is even, then what we'll do is just be making pairs with one of the odd elements and traverse to the entire array, and the answer would be then equal to the number of even numbers. So I hope you understood what needs to be done in the question. Now here's the code of my problem, and I've taken t as input, which denotes the number of test cases, and if we go up, then you see we have n, and x denotes the size of the array as mentioned, and even takes the count of all the even elements in the array, or takes the count of all the odd elements in the array. And then we'll take input. If an element occurs which is odd, then odd will be incremented. If even element occurs, even would be incremented. If even is equal to n, that is if all the elements are even and x is also an even number, then we would return -1. Otherwise, if x is odd, then the answer would be even plus 1 upon 2, else the answer would be even. So I hope you understood this problem. This is another problem that came in the contest. It's called construct array, and we are given a positive integer n. We have to construct an array of length n, and let pi denote the sum of the first I elements of A. So let's suppose the array has size 4, and pi would denote, like if we take I equal to 2, then pi denotes the sum of the first two elements, and si would denote the sum of the last two elements. If we take I equal to 1, then pi would denote the sum of the first element, which is the first element itself, and si would denote the last element. Okay, we need to construct the array of size n, which has the following conditions. So all the elements of ai should be between the range of -10 to the power 9 to 10 to the power 9. Okay, if I is odd, so let's say if I equal to 1 or I equal to 3, then pi should be greater than si. So if let's say we have I equal to 4, then it would be an even number, then pi should be less than si. So this question is trying to say that if we take first few elements and last few elements, and if I is odd, then the first few elements sum would be greater than the sum of the last few elements of the array. And if we take I to be even, then the sum of the first few elements would be less than the sum of the last few elements. We can print multiple solutions. I mean, there are multiple solutions possible. We can print any of them, and if there is no such array, we have to print -1 instead. Okay, so this was quite an observation based problem, and if you have enough practice, this could be figured out, though it's not that easy to figure out the solution, but it can be figured out if you have enough practice. These type of questions come under the category of constructive algorithm questions. So let me give you the hint. So here is the array. We have a1, we have a2, we have a3, and this extends up to an. So we were given that the sum of the first odd elements is greater than the sum of first even elements. That clearly means that the first element would be greater than the last element. A1 would be greater than an, and if we have a1 greater than an, then it was also given in the question that the sum of the first even elements is less than the sum of the last few even elements. So if the size of I is 2, and here we have a n minus 1, then the sum of these two elements would be less than the sum of these two elements, but this element was greater than this element, so we would have to make this element larger than this element, and by a very good margin, so that we can recover the gap which was made by this element. Now the sum of first three elements would be greater than the sum of the last three elements, so again this element should be greater than the element which would occur here, which would be a n minus 2, and to fill the gap of this element or the sum of these two elements, this element should be much larger than this element. So the corresponding elements like ai and its corresponding element would be a n minus I plus 1. So these two corresponding elements can never be equal. These two can never be equal. So this clearly gives us the hint that the size of array can never be equal to odd. Why am I saying this? Because the middle element of an odd sized array is always, if we take the middle element of the array, let's say we have 7, the size of array is 7, and the middle element would correspond to the fourth value, and from end it would be the fourth value, from front it would also be the fourth value. Let me show it a bit more clearly. 1, 2. So let's say we have 5 size array, then the third value, which is the middle value, would be same from this end, it is the third value, and from this end also it is the third value. But from our observation it was quite clear that the corresponding element from front and back can never be equal. So this clearly gives us the indication that for all odd sized array the answer would be -1, because no such array would exist. Okay, so the first deduction that comes from this problem is that for odd sized array answer can never exist, so it would be -1. Now let's construct the array for even elements. So let's suppose I take my first element equal to 1 and the end element equal to 0. Let's suppose we have an 8 sized array. Then the sum of these two, because it was given that the sum of first few elements, if are odd, then it would be greater than the last few elements. Okay, then the sum of first two elements should be less than the sum of the last few elements. So let's suppose I take 0 here, and in the end I will take 2. So it clearly shows us that the sum of the last two elements is greater than the sum of these two elements. Now for the sum of first three elements, here the number should be greater. So here would we take 2, and here we would fill it with 0. So the sum of the first three elements is clearly less than, greater than the sum of the last three elements. Now the sum of the first four elements should be less than the sum of the last four elements. So here we would take 0, and here we would take 2, and it clearly shows us that the sum of first four elements is less than the sum of the last four elements. if we extend it beyond this, sum of first 5 elements is equal to 2 plus 2, it is equal to 5, and sum of last 5 elements is equal to 4, which means that this one is greater. The sum of the first 6 elements is equal to 5, and sum of last 6 elements is equal to 6. So the last few elements win, and the sum of first 7 elements is greater than the sum of the last 7 elements. So if we construct the array by this property, then it is quite evident that we would get the result. So let's check the code now of this problem. So here is the code of my problem. I have taken t test cases like this, and then I will take n as input. If n and 1 equal to 1, that means if n is odd, then our answer is never possible, so we'll return -1. Otherwise, first we would print 1 as it is, and then we would make a loop, and if I is odd, then we would return 2, otherwise we would return 0, and this would help us in constructing the array, and at the end of the array we would always have 0. So this gives us the final answer, which was valuable. I hope you understood the explanations. If you think that there could be any sort of improvement, please comment it down in the comment box, and thanks for watching. I hope you like the video, and share it with your friends and subscribe to the channel. Thanks.